So we can see for this problem, it gives us a bunch of data. So we want to write that down. It was 20 cents, and then 80, and then 45, 65, 30, 55, 40, 40, 30, 55, $1.50, 40, 65, 40. So then we go to StatCrunch, and we're going to enter this data. So 20 cents, 0.20, 80 cents, 0.80, then 0.45, 0.65, 0.30, 0.55, 0.40, 0.40, 0.30, 0.55, $1.50, 0.40, 0.65, and then 0.40. And then you go to Stat, and then Summary Stats, and Column 1, and say Compute. So we see our mean is 50.5393. If you round this, 0.5393. And our standard deviation is 0.31996, which would actually round to 0.320. So when you enter this into WebAssign, you see this little cents. You're going to, instead of entering 0.5393, you're going to move a decimal over twice, so it's 53.93. And instead of entering 0.3200, you're going to move the decimal twice, so it's 32 cents and 53.93 cents. N is also given in StatCrunch. N is 14. And then your n minus 1 is 14 minus 1, which is 13. For part B, X and X bar. So X is the number of cents off for a coupon, and X bar is the average number of cents off for a sample of coupon. So X bar is the average number, and the distribution is going to be T13. And you're going to use the student t distribution for 13 degrees of freedom because the sample standard deviation is known. Now to find a confidence interval, now the answers are showing it's 35.45 to 72.40, but how they got that is you would go to StatCrunch and you go to Stat, T-Stats. This is one sample, and we are actually given data here. And here is the column, and we want a confidence interval, and I think it said 95. So we should double check. 95% confidence interval, yes. So 95% confidence interval corresponds to this is your lower limit and your upper limit, but since there's a little cent sign, you want to move the decimal over twice. So this is 35.45. And that's how they got this answer, 35.45. And then for the next one, you move the decimal twice, 72.40. So 72.40, and right here is, you can see the answers, 72.40. Now 95% goes in the middle, 0.95, and then you have 5% left over. 5% divided by 2 gives you 0.025 on either side. And then the 35.45 goes here and here, and the 72.40 goes here and here. Now the error bound, to figure out the error bound, you can take you can actually take this number, 72.40, and subtract it from your mean, which is 53.93. And that will give you your error bound. So you take this number, 53.93, and you subtract it from 72.40. And when you put that in your calculator, 72.40 minus 53.93 gives you 18.47, which is your error bound. And then for part E, if a random sample were taken of size 14, what percent of the 95% confidence intervals constructed should contain the true population mean worth a coupon? So 95%. So if you did this 100 times, 95% would contain the true population proportion. A 95% confidence interval means that 95% of all possible samples will result in an interval that includes the population average worth of coupons.